Hi, welcome to the video tutorial for exercise number 40 of the basic part modeling exercise set. Today we're going to model this model here. It's a pretty simple one. We'll get it done pretty quickly. Even if it looks intricate, there's nothing too complicated to it. With that said, first thing to do when you open your new SolidWorks file is to set down here the units to inches, because the model here is given in inches. After that, when you look at the model, you'll notice it is comprised mainly of cylinders. Well, some of them are modified, but you can see here we have one cylinder, here we have another one. This plate here is like a flat plate cylinder, and also this here, this face, is a cylinder that has a lot of cuts introduced to it. And we know it's a cylinder because here we have a diameter dimension for this face. So knowing that, we know that using a revolve extrusion is going to be the easiest way to sketch this and make it into a 3D model. So I'm going to draw in this case on the right plane. You can choose any plane you want. First, I'm going to draw a center line up here. Select the center line, make it horizontal, and I'm going to make it infinite length. And this is going to serve as my reference when drawing the profile, as basically the center of all the circles, the central axis of all the cylinders we made. After that, since we have 4 cylinders, I'm going to draw 4 rectangles as my profile. And I'm going to use this point here as the origin, so that coincides with the front of this face here. So that's going to be basically 4 rectangles all joined together, joined in this way. And I can draw it as one single profile so that I can extrude it all at once. Now you'll want to check that all the lines that you drew here are either horizontal or vertical. And in case you're not sure, you can just here click this icon to show the sketch relations and make sure that it shows all of them as horizontal or vertical. Now, seeing that that is the case, I can start to dimension this and actually bring it into the correct size. First, I'm going to set the thickness basically of each cylinder, the distance from the separation from the cylinder to the origin here. So for the first two, we have 0.2 inches, and then for the next one we have 1.2 for this one, and for this one we have 2.3 inches. So that would be using the Smart Dimension tool. Click this face here, and set the separation as 0.2. Same thing with these two. And then from this face here to the origin, we have 1.2 inches. And from this one here to the origin, if I remember correctly, it is indeed 2.3 inches. The next dimension to set is the diameter of each of the cylinders. The first one has a diameter of 3.75 inches. I can get that from selecting the face here, or the line that will become a face here, and then click in the center line. Now if I have it here, this is not going to be the diameter but the radius, right? Just half the diameter. However, because I used a center line, I can just drag it down here and here set the actual diameter. So that's 3.75. The next one has a diameter of 4 inches, so the same thing, select the line. And already it's selected to the center line, and same thing, just click anywhere. Set it to 4 inches, followed by 2 inches for this one, you'll see here. And for this one, we have 1.2 inches. You'll see this edge here corresponds to this edge here. It's all the same cylinder with a little cut here. We'll go into that later. But at the moment, the last one is just 1.2 inches diameter. And that has our whole sketch fully defined. We can tell because all the lines are dark. And we can go ahead and in the Features tab, choose the Revolve option. And this is the basic shape of the model, you'll see. It looks vaguely similar to this. Now, after that, we can start sorting out the smaller details in the model. First, I'm going to introduce these cuts here. You'll see there's one here and one opposite to the other side, and we can tell they're separated by 0.8 inches. And they go 1.7 inches deep from the origin here. So, in order to make those, I'm going to have to sketch a couple of rectangles on the top plane. So I'll make myself normal to it and start a sketch on it. And I'm going to use the corner rectangle, because I think it's the easiest function in this case, and go from this corner here to somewhere that looks vaguely correct. So maybe like there. And then, well, it's just a rectangle, so all the dimensions are set already. We can dimension it. First, we have this edge here, which would be this edge here, is 1.7 inches away from the front, so from the origin. So I click the origin and click the face here, or the line there, and sure enough, it's 1.7 inches. After that, we're told that from one side to the other, we have a separation of 0.8. Now, I haven't drawn another rectangle yet because I'm going to mirror it later. So what I can do, in my case, is select this face here and select the origin. And the origin, you'll notice, goes vertically down the middle. And set this as half of 0.8. And if you feel too lazy to calculate that in your mind, you can just put 0.8 divided by 2. And you can do math inside of the SolidWorks Dimension tab. So I'm going to accept it. And I'm going to use that sketch here, now fully defined, to make extruded cut. And here we're going to choose the appropriate type of cut, which in our case is going to be through all, but not just through all on one side, but make sure to choose through all on both sides, so that it cuts everything that it finds perpendicular to the sketch in either of the directions. So I'm going to cut that, accept, and now still in the features tab, I'm going to mirror around a face or plane. I'm going to choose in the feature manager, I'm going to choose, in our case, the right plane that goes down the middle here, you see. And as the feature to mirror, I'm going to choose this face here, and it's going to tell it, when you choose the face that comes from the cut, SolidWorks selects the whole cut. And now you see we have the whole cut again mirrored here in the preview. So just accept that. And that is exactly what we need. Now, in order to make the cuts you see here into this face, we're only going to actually draw one of them. And the rest we're going to use a circular pattern to have SolidWorks draw them automatically. So if we look at one of them, we have this one here that has this horizontal line as its center. It's horizontal to the origin. It's composed of two horizontal lines separated by 0.3 inches going all the way to the circumference. And what I'm going to do is, instead of drawing both of these lines, is I'm going to draw this line here and this line here. So in order to do that, I'm going to have to start a sketch on this plane, the front plane, mind you. And I'm going to, right click it and choose sketch. And I'm going to make a line that's not exactly to the side, or it's not exactly horizontal to the origin, but it's slightly below, but it does start at the circumference here. So click there, make it horizontal. You see here, I get the snap option for horizontal, and draw one here. And that's the basic shape. That is the basic shape of our cut here. We also have to close it now. And that we're going to do with a center point arc with the same center. And it's basically just a little section of the circumference. Just starting one end, bring it down to the other end of the two lines you drew. So in order to set the right relation and the right proportions between these two, we have to set them as having the same length. So you click one of them and then control click the other one. So you select both. and you set the equal relation as true, accept, and we have to set, using the smart dimension, we have to set the angle between them. So you click one, click the other, and set the angle to 15 degrees. And now the only thing left is to find a separation between this line here and the horizontal that comes from the origin. And that I can do. We said it's 0.3. Well, it's 0.3 from one to the other one, so half of it's going to be from one to the origin. Using smart dimension again, choose the horizontal one, and also click the origin. And again, if you're feeling too lazy to divide, just write 0.3 divided by 2, and SolidWorks can actually do it on its own. So that's it, fully defined, everything dark. We can now use this sketch to make an extruded cut again. In this extruded cut, you can use the blind option and fill it into 0.2 inches, or it goes all the way here, but an easier way to do it is to select the up to surface function, and now select the surface we want to bring it all the way to, and it's this one here. You see, we want the cut to go from this face all the way to this face, so it becomes a single face. You know, this circular part here and the little triangle we're going to cut away. Accept, and you see the cut goes and stops at the face we specified. So that's one of them drawn, but we need a lot of them. We know that they're separated by 15 degrees. What we're going to do in this case is use a pattern, but not a linear pattern, but a circular pattern. And in order to set up the pattern correctly, we're going to actually need one of the temporary axes that we created before. And that you can do from this tab here. Show. Here you have normal axis, but here you have temporary axis. Select that, and you see these are the axes from all the cylinders we drew right now. Or the ones we drew from the beginning, right? All the cylinders that we created have axes going through the center of them, and we're going to use those as a reference. So here, as a reference, or the pattern axis, we're going to use one of these patterns. And as the feature to revolve, we're going to choose the cut. You can do that by just clicking one of the faces created by the cut. And now you want to set them as separated by 15 degrees because you know that much, and you probably haven't counted all of them. I certainly didn't. So what you can do is with this function here, just increase, right, set the angle to 15 first, and then just increase all the way until it goes all the way around, and after that it's not gonna let you create any more because it's just drawing over itself in a way. And also, well, if you're quick, 24 times 15 makes 360. So that's a full circle. And that's that done. Not bad. After that, we only have left these holes here. And these are counterbore holes. And we're given their dimensions by these, these dimensions here. And we're given this symbol here. And this is the symbol for a counterbore. A counterbore is just a hole with a flat face at the bottom of it, and with its walls, the walls of the hole are vertical, relative to the flat face at the bottom. So what we're told here is that the hole has a diameter of 2 inches and a depth of 0.2 inches. That's what this means, right? The diameter, you know already, and this is the depth indicator. So the first one, this one here, we're going to draw on this face, but before I do that, I'm going to hide again the axes I showed before, just for convenience. Hide them. Well, it's still showing this one, but it doesn't matter. And right click this face, make myself normal to it, just for ease of drawing, and sketch. And I'm just going to draw a circle from the origin, smart dimension it, to that's 2 inches. And make extruded cut again. Again, this is a blind cut, and the depth is going to be 0.2 inches. Right. Then inside of that one, we have this one here. And that one, we're told, has a diameter of 1.4 inches and again, a depth of 0.2. So now we're drawing in this face here, the one we just created with the cut. Right click and select sketch. And again, make a circle from the origin, diameter 1.4. And once more, select extruded cut in the features tab. And 0.2 once more. That's another one done. And then we have this one. And this one we're given a few details at once. We're given 2 diameters, but you see this one has a counterbore symbol and this one doesn't have any symbol next to it. And we're given a depth of 3 inches, or of 0.3 inches rather. So what this means, and if you look here, it's a bit hard to see, but the bigger diameter is corresponding to the counterbore. So we're gonna make a counterbore, a hole with a flat face, with a diameter of 0.6 and a depth of 3, and inside of that we're going to make a 0.4 diameter hole that goes all the way through. So if that's a bit confusing, I've made a model here beforehand, and you'll see so far we have drawn this face. So this circle here, this face, is the 0.6 diameter one with a depth of 0.3. And inside of that one, we have this hole that goes all the way, and that has a diameter of 0.4. So again, select the last face we created, make ourselves normal to it, and create a sketch. Make a circle from the origin. Set diameter to 0.6. Make an extruded cut of 0.3 in this case, no longer 0.2 in depth. And we have another hole there. For the last time, create a sketch in this face here. Let's draw a little circle from the origin. And oh, we have to dimension it. Excuse me. 0.4 diameter in this case. And an extruded cut, in this case, through all. We're not given a specific depth, so we're just going to draw it through the whole thing. And for that, we select through all, and it goes all the way through, no matter the size. And that's it. You have the hole that goes all the way through, and all the holes inside that we see here. The last thing is this bit here. Maybe it's a little bit difficult to see, but you'll see there's a really sharp edge in this point here, and that's because from this dimension we have a chamfer here. And even though we're not really shown here, you can maybe see it here a little bit, not very clearly, that we have a chamfer up top and a chamfer at the bottom. So that's going to be this edge and this edge. So in order to make the chamfers, we're going to go to the fillet option, and instead of choosing fillet, we're going to use the drop down menu to select chamfer. And we're going to select the edge that we want to chamfer, being this one. Now this looks really odd, but don't worry, that's going to fix itself once we do this. And also select this face here.